Hello everyone. Today we'll be solving a problem called odd even linked list in LeetCode. So let's go through what the problem is. Given a singly linked list, group all the nodes together followed by even nodes. Please note that here we are talking about the node number and not the value. You should try doing it in place. So in place means you have to not use any extra space. The program should run in O of 1 space complexity and O of nodes time complexity. So as it's clearly mentioned here, to avoid confusion, we are actually talking about the node index number and not actually the node value. So if you see here, the initial input given is 1 pointed to 2 3 4 5. So all the odd indexes are basically 1 3 5, assuming index is starting from 1. So 1 3 5 are grouped together followed by 2 4. Similarly, if you see this example, you have you have this input, and the output will be all odd indexes first and then even indexes next. So 1 3 5 7. So 2 3 6 7 will be the first odd index nodes list, and then followed by even index nodes list. So one thing you have to remember is that the relative order should remain same because it's mentioned in the constraints here, right? So let's start the code. So what I'll be doing here is, first, so I'll be creating two dummy nodes. Okay, so we already have a list node here. So using this list node, I'll be creating two dummy nodes. So basically, let's say so I'll create two dummy nodes called even and odd. So the even is initially pointed to -1, or anything you can point it to anything. I'm just taking as -1 to avoid confusion. And even temp is also pointed to -1. Similarly, I took a dummy node called -2, where odd and odd temp are pointed to -2. So you might be wondering why I have taken extra even temp and odd temp. So we'll get to the details once we start the code. So from the pictorial representation, I'll start defining the nodes. So first, let's create the even node. I'm calling it even. I'm calling it even. So it's list node of -1. So I'm also pointing even temp to this. Similarly, for odd will be -2, right? Odd and odd temp will be pointed to -2. So we have created two dummy nodes. So now, so the idea basically is, so first we will iterate to the entire linked list, and we will group all the odd index nodes and we'll attach it to the odd dummy node. And similarly, we'll group all the even nodes and we will attach to the even dummy node, and finally we'll combine these two. So I'll show you how it's done. Yeah, so let's say this is the given linked list: 1 pointed to 2, pointed to 3 4 5. So as I am saying, we have -2 initial dummy node. So once we traverse to the first iteration, we'll be getting all odd index nodes, so which is 1 3 5. So all these 1 3 5 I'm attaching to the odd dummy node, and all the even index nodes, which is 2 and 4, I'm attaching to the -1 dummy node, right? So once this is done, what I'll do is I'll attach the odd I'll attach this I will attach this even linked list to end of odd linked list, which will give the final result and serve our purpose. So that will look something like this. So this 5 is pointed to, okay. So then finally we'll get the desired output, which is basically 1 3 5 2 4. Don't worry, we will eliminate -2 and -1 in the process. So this is the odd index nodes and these are even index nodes. So whatever is shown in the picture, we'll try to represent the same in the code, right? So first, let's iterate to the linked list. So as long as head is not null, How do you know the current index of the node? So let's take a count index 0. So if count mod 2 is 0, it means it's an even index, right? So if you are at an even index, so that means that node should be attached to the even dummy node, right? So since you are at the even index, so first we will be not, so initially count will, oh sorry, let's start from 1 actually, since the index is, we are taking from 1 here. Yeah, so if the count initially is even number, so we'll be attaching that to the even dummy node. So basically it will be even dot next will be equal to head, right? And then you are advancing the even pointer also. Even will be equal to even dot next. So if the index is an odd number, then we'll attach it to an odd node, dummy node that we have created. Odd dot next will be equal to head, right? And then we'll advance the odd pointer also, odd dot next. So now we have attached whatever necessary. Time to advance the head pointer also. Head equal to head dot next. So now we advance the head also, right? So once you complete the entire iteration, now you have two different lists ready like this. After while loop you will be getting ready with this. So now all you have to do is attached even linked list to the tail of the odd linked list. So how you will do it? So we have this odd pointer currently at 5, so odd dot next will be equal to 2. We have to attach it to 2, but since we have even pointer here, we'll utilize the even temp pointer, which is initially pointed to the -1. So this is the reason exactly why I have created this even temp. So now odd dot next will be equal to even temp dot next, which is 2. So let's do that. So odd dot next will be equal to even temp dot next. So what we are doing is we are attaching the even indexed nodes list to the tail of the odd ones, right? So you have successfully linked now, right? So now what you will be getting the final what do you think the final answer will be now? We have attached 5 to 2, but we still have our odd temp at 2 -2, right? So but we don't want the dummy node, we just want the head, which is 1. So again you will be advancing, so you'll be returning odd temp dot next, which will pointing at 1, which will be pointing at 1, right? So you'll be return odd temp dot next. So one thing you might be missing, the tricky part here is the end of the even list. The next pointer is it should be pointed to null, as this is the end of the list. Otherwise you'll end up in winding up a cycle and it will be time limit exceeded. So even dot next will be pointed to none, right? So point the last node to none or null, as it's the last node, or as it's the end of the list, right? So what we are doing here, we are basically returning the head of the new linked list, right? So here we are basically checking if the index is even, and this will be odd, right? So this is the dummy node for even, so this is the dummy node for even based list. Similarly, this is a dummy node for odd based list. So this is just a variable to know what is the current index, and we also have to increment it, right? Let's increment it here. So because while we are traversing, if you increment, then only we'll get to know the current index at any given point of time, right? So let's submit it. Yes, success. So this is it, guys. So let's discuss the time complexity of this. So since we are traversing the whole list, the time complexity will be O of n, where n is the number of nodes in the given list, okay, given linked list. And coming to space complexity, we are using two helper pointers. So we just created two dummy nodes, so we can consider them as a constant space. They don't really take much space, so constant space complexity, right? So yeah, this is the time complexity and space complexity. Thank you for watching, guys. Please subscribe to my channel for more number of problems.